In this video, we are going to be talking about dividing radical expressions and using the quotient rule to simplify rational expressions containing radicals. For example, if I have a rational expression, so a divided by b, all of that taken to the nth root, you can break that up into the nth root of a divided by the nth root of b. Or you go back the other way. So if I had a quotient here with the nth root of a divided by the nth root of b, if they have the same index, I can bring that back together under one big radical sign and then simplify the fraction within. So we're going to do that. We need to be able to go back and forth between using this quotient rule for radicals. For example, I have here the square root of 75 divided by 81. So what I notice is in the denominator, there's a perfect square. So I'm going to go ahead and split this into the square root of 75 divided by the square root of 81. Now, it is true that you could actually simplify this fraction, but because that denominator is a perfect square, and in general we don't want radicals in our denominator, I'm going to go ahead and split that up. Then I can simplify what I have. So in the denominator, the square root of 81 is just 9. In the numerator, that's not a perfect square, so I factor it. That is 3 times 25, and 25 is 5 times 5. So there's my perfect square. I can take the square root of 5 squared and get 5. And then the 3 didn't have a buddy, stays underneath the radical. There was not a perfect square. Can't take the square root of it. And that's as far as we can go. Alright, now let's look at this next one. Below it, I have the square root of 64x to the 5th divided by 2x cubed. While it's true that 64 is a perfect square, in general we do not want square roots or radicals in the denominator. So I'm actually going to simplify this fraction first. So I can, if I didn't have that radical sign there at all, and I was just simplifying 64x to the 5th divided by 2x cubed, we would divide. 64 divided by 2 is 32. X to the 5th divided by x cubed, well, we subtract the exponents. 5 minus 3 is 2, so I get x squared. And I have not used that square root yet. All I've done is simplify this rational expression to 32x squared. And now actually I don't have a denominator at all because it divided evenly. And with all like with all our other radicals, we need to simplify what's left. So 32 is the same thing as 2 times 16, which 16 is a perfect square. It's 4 times 4. So I can take the square root of 4 squared is 4, and that 2 is going to stay underneath the radical. I also have this perfect square. The square root of x squared is x, and then as we mentioned before, the only thing left underneath was this 2. So now I have 4x square root 2. You go ahead and try the 3 here on the right hand side. Okay, let's see how you did. Looking at this first example A, it says the square root of 1/64. 1 and 64 are perfect squares. Square root of 1 is 1, square root of 64 is 8, and that's all I have to do. Versus this next one, I have the square root of 32 divided by the square root of 2. They're both square roots. Neither one of them are perfect squares. So what I can do is I can bring it back together under one radical and simplify the fraction first. So 32 divided by 2 is actually 16. Square root of 16 is 4. which is much nicer than what it looked like before, right? So if we have a fraction that we can simplify, you should try to simplify it or bring them together under the same radical and then simplify and then take the square root. Versus here in this next example, there's really nothing here I can simplify. There's no common factors, so we break it up using the quotient rule. Whoops, that's a W. Amongst the numerator and denominator. And then we can actually break it up even further using the product rule. So W to the 8th, take the square root of that, take the square root of x cubed, and the square root of 16. Bring all that down here. Square root of W to the 8th, remember we can just divide 8 divided by 2 because the index here is 2 for a square root, and we get W to the 4th. Because W to the 4th times W to the 4th would get us back to W to the 8th. X cubed is not a perfect square. It is the same thing as x squared times x. See, I have 2 x's and this makes 3. The x squared I can take out. The x has to stay underneath. So the square root of x squared is x, and then I have this other x left underneath the radical. Then in the denominator, the square root of 16 is 4. And that's as far as you can go. Alright, so get used to using that rule, simplifying a fraction first or a rational expression first and then evaluating that radical, or evaluating the radical separately across the numerator and denominator.